All right, you guys, let's take a look at 11.3a. So it says it's talking about rates of change. So calculus is the study of rates of change. Slope, which you guys have been learning about for years, is a rate of change. Okay, so a line tangent to a graph of a function at point P, x, y is the line that best approximates the slope of the graph at that point. So like here, the slope of the line would be a line tangent to the graph. The slope of the line would be a line tangent to the graph. And remember that a line tangent to the graph creates a 90-degree angle at that point. So to find the slope or the rate of change of a graph at a point, we need to find the slope of the tangent line at that point. So we're going to actually teach you kind of how to do that. Okay, so the first one says approximate the slope of the tangent line visually. Okay, so right here, okay, we could take this from here to here and find this slope. So here's the point that we're looking at, but we're going to take this section of line right here. So if we take this section of line, we're looking at rise, and our rise would be 1 over our run, which would be 1. So our approximate slope would be 1 for that one. All right, let's take a look at this next one. Okay. So this next one right here, I'm going to look here and here, okay, for this tangent line. So I'm going to go up about that much and over about that much. So here, looking at this, that kind of makes it hard. I like to have my numerator be a whole number. So I'm going to go up 1 and then go over to there. Okay? So my slope then would be up 1 and over 2. Otherwise, it would have to be up 1/2 and over 1, okay, which would still come out as 1/2, but I just like it to be nice and neat and pretty like that. Okay? All right, so that is how we approximate the slope of a tangent line visually, right? We're just going to find the slope by looking at it and doing rise over run. But let's take a look at a couple. You know, we're in pre-calc. It's going to get a little more difficult. Okay, so let's take a look at a couple of more examples, and then we're going to get into actually calculating slope. So the graph depicts the average daily temperature in degrees Fahrenheit for each month in Dallas, Texas. And it says approximate the slope at the indicated point and give a physical interpretation of the result. Okay, so our first thing here, at this point, what is our slope going to be? So I'm going to kind of say from here to here. Okay, so my rise is going to be 20. Okay, and my run would be 2. Okay, so my slope is going to be 10. Okay, so my approximate slope is 10 degrees, okay, or 10. What that means is at this point, our temperature is rising, right? So that's our temperature right there, is rising 10 degrees per month. Okay. And, you know, if I was looking over here, right, my temperature would be decreasing per month. If I was looking here, my temperature would be steady, okay, or pretty close to steady. Okay, so this means that at this point on the graph, this point right here, that fourth month, okay, 65 degrees, that means that my temperature is rising 10 degrees per month. Okay. So you're going to have to be able to interpret what these slopes mean because they're actually used for things in real life. Okay, let's take a look at, now we're going to actually start talking about how to find limits and how limits and slopes correlate to one another. So this says using a secant to estimate a tangent. So the first thing is we're going to find the coordinates of points. So here you can see that we're finding the coordinates of different points. Okay, there to there, there to there, there to there, and you notice that these get closer and closer and closer until finally we're just at one point. And it doesn't matter what those numbers are, okay? It's just showing you the method. Okay, so as the points get closer and closer to each other, the slope approaches that of the graph at the tangency. So as we find this slope and this slope and this slope, finally to this slope, these get really close to each other and they approach the tangency. Okay, well, this y value for these secant lines is this right here. Okay? The x value is equal to h. So really that's our rise over our run. Okay? So provided that this limit exists, okay, that is our formula that we're going to wind up using. So, and you guys have seen this before. We've worked with it before. We're going to work with it a few more times. Okay? Right, so a lot actually. You're going to see this a lot. So let's find the slope of the graph f of x equals x squared at the point -2, 4. Okay, so here, what we need to do is we need to find the limit as h approaches 0. And we're going to use this formula up here that we just had. So f of x plus h minus f of x all over h. Okay, so now let's go on ahead and let's solve this. Okay, we got to actually plug this stuff in, okay, for the function. Okay, so our function is x squared. Okay, so anywhere we see an x, we're going to plug in x plus h. Okay, so for f of x plus h, we're going to get x plus h squared, which is really going to be x squared plus 2h plus h squared. Okay, then we need to do this portion. So we're going to do f of x. Okay, well, that's just the original function. So that's just our x squared in this case. Okay, so now we're going to do minus, because of this minus sign, x squared. All right, so now let's go on ahead and cancel out what we can cancel out. Oh, and this is actually, see, that's what I get for not writing it out. X plus h times x plus h. I'm going to go on ahead. So that would be x squared. That would be 2xh. There we go. All right, so those cancel. Okay. And now I'm left with 2xh plus h squared all over h. Let's pull an h out from up there, and I'm left with 2x plus h all over h. Okay. And now I'm left with 2x plus h. Okay, so now I'm looking for my limit as h approaches 0, okay, of this function right here. So if I plug a 0 in here, I'm left with 2x. Okay? So this is my slope. So my slope equals 2x. So now if I just plug that in, so now I'm going to plug in my point -2, okay, and let's see what I get. So I'm going to get 2 times -2, and my slope at that point is going to equal -4. Okay, so here's what happened. I used this formula, okay, and I plugged in, and I found my slope just by canceling and finding h, the limit as h approached 0. So that gave me my slope. From there, I can plug in a point and find my actual slope at that point. Okay. We're going to do a bunch of these, okay? So there's two versions of slope. Finding the slope at a specific point. Okay, so this right here is where you're actually plugging this in. Okay. Okay, so this is where you're actually plugging in the specific point, okay? And the other one is just finding the slope formula. Okay, so there's two different things that you're doing here. Okay, so let's actually take a look at these. I don't know why this is kind of weird, but oh well. So the first one is going to be find the formula. Okay? So the first one, we're looking for the formula for f of x. Yeah, if I can write, that would be great. Equals x squared plus 1. Okay, and then I'm going to go on ahead. The next one, we're going to find the actual slope at this point. So -1, 2. Okay, so I can get rid of this sheet of paper, and now we can find the formula. So in order to find the formula, I have to use my original value. Okay, so My original value is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So my very first step, I need to find f of x plus h. That's always going to be my first step, to find this first part. Okay, so anywhere I see an x, I'm plugging in x plus h. So x plus h squared plus 1. So that's x plus h. I'm going to go ahead and write it out this time, since last time I kind of made a little mistake. All right, plus 1. So that's going to be x squared plus xh plus xh plus h squared plus 1. It's going to be x squared plus 2xh plus 1. And then it's going to be minus this f of x, so the function, okay? Remember that f of x really is just that function. So minus x squared plus 1. So now I'm just going to distribute this minus sign. So x squared plus 2xh plus h squared. Oh, see, I forgot that h squared here. Plus h squared plus 1 minus x squared minus 1. So I distributed that minus sign. Okay, these are going to cancel, these are going to cancel, and I'm going to be left with 2xh plus h squared. As anytime you do this, because we're always looking for the limit as h approaches 0, we have to have stuff with h's in here that we can take an h out, okay, because we have to get rid of this h in the denominator. So if you don't get every term up here having an h, you've done something wrong, and that's how I knew I had forgotten that h squared up there. So I'm going to pull an h out, and I'm left with 2x plus h all over h, and those h's cancel. Okay, so now my slope is going to equal 2x plus 0, okay, which is just 2x. Okay, so that's my function. Okay, my slope, or my slope equation. Now all I'm going to do is plug these in. Okay, so I'm going to say 2 times -1 equals -2. So that is my slope at that point. But at this point here, my slope's going to be different. 2 times 2 is going to equal 4. Okay, so at 2 different places, I have 2 different slopes. So this one right here says use the limit process to find the slope at the given point. Okay, so we're going to do the exact same thing that we just did. All right, so let's see. So we're going to find the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so the first thing we need to do is we need to find f of x plus h. Okay, so that's going to be 4 over x plus h. And that's going to be, that's it for that one. Okay, so now we're going to do this minus this. So now we're going to do 4 over x plus h minus 4 over x. Okay, well, now we have to get common denominators. So this is missing an x, and this is missing an x plus h. So I have to multiply. I have to multiply. This I have to multiply by x. And this down here I have to multiply by x. All right. And that's all going to be over h. All right, so I'm going to get, let's see, 4x minus 4x. And I'm just distributing this minus 4 minus 4h all over x times x plus h all over h. All right, so let's go on ahead. Those are going to cancel. And I'm left with, oh, those are going to cancel. And I'm left with my minus 4h here. So I get negative 4h over x times x plus h all over h. Well, now I'm going to have to multiply by 1 over h here. So that's going to be times 1 over h. That h is going to cancel with that one. And now I am left with negative 4 Okay, negative 4 over, oh, here. I'm going to move this over here. So negative 4, so I'm multiplying this right here, okay, because I multiplied. Negative 4 over x times x plus h, and I want the limit as h approaches 0. Now this one's okay because there's other stuff down here, right? So I'm going to have negative 4 over x times x plus 0, which is x, which gives me my slope is negative 4 over x squared. Okay, so that's my slope equation. Okay. So that one was a little bit more difficult, okay, because you actually had to deal with a reciprocal. But remember, dividing by a number is just the same as multiplying by its reciprocal. Okay, so we can do that. That's okay to do. Okay, pay attention. Make sure that you know that this just means I'm plugging x plus h in anywhere I see an x. Okay, and then I'm just subtracting the original function. All right. So once you get the hang of that, it usually comes out a whole lot easier. Okay. All right. Have a great day. I'll see you guys next time.